Gravitational Force by Madame Rosmaya. Who discovered gravitational force? Sir Isaac Newton. Sir Isaac Newton was an English mathematician and physicist who lived from 1642 to 1727. The legend is that Newton discovered gravity when he saw a falling apple while thinking about the forces of nature. Whatever really happened, Newton realized that some force must be acting on falling objects like apples, because otherwise they would not start moving from rest. Newton called this force gravity and determined that gravitational force exists between all objects. In his Law of Universal Gravitation, Newton stated that every body attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. In mathematical form, we write as F directly proportional to the product of the two masses m1 times m2 divided by distance between them, r squared. When you put equals, F equals 2, we must put together the constant g, m1 times m2 divided by r squared, where g is the constant of proportionality known as the universal gravitational constant and has a value of 6.67 times 10 to the power of negative 11 Newton meter squared per kilogram squared. The force is always attractive. Sometimes this force is written with a negative sign to indicate that it is attractive. The video below can be used to visualize the gravitational force. You can visit the given URL to watch the video later. You need to spread a cloth, example lycra cloth like in the video. Then you put two objects on the flat cloth and observe how the cloth bent because of their masses. The bend caused the curvature on the cloth surface. Observe how the two objects move towards each other. Okay, this represents the gravitational force between the two objects. Part of the planetary system, we know that the Earth orbiting the Sun and the Moon orbiting the Earth. Okay, the lecturer now is going to show this analogy. Observe how the lecturer put object with larger mass on the cloth. And this time, he will make the other object to orbit around the big object with larger mass. Observe that the attractive force between the two masses still exists. Okay, we observe this video just to visualize and understand the gravitational force, and we are not going to discuss the phenomenon in detail. The animation below can be used to visualize the gravitational force as a gravitational warps in the fabric of space and time. Okay, Newton's law of gravitation is an example of an inverse square law. If the distance r doubles, the force F drops to 1/4 and so on. As a result, the effect of gravity falls rapidly as the distance increases between two objects. The analogy of inverse square law can be observed using blue spray paint. Suppose you squirt a dose of paint on a wall. You then deliver the same dose of paint from twice as far away and compare how much larger is the new spot and how thick is the paint. Remember that area is length times width. Since the new paint spot is both twice as wide and twice as high as the original, it covers 4 times the area. As a result, the paint is only 1/4 as thick as before. At triple the initial distance, the paint spot has 9 times the original size. The paint is only 1/9 as thick, and so on. In math speak, the concentration of paint follows an inverse square law. We try this example. Two students of masses 50 kg and 40 kg are seated 0.50 meter apart. Calculate the gravitational force between them. Hence, explain why the students are not accelerated towards each other. The solution, using the formula F equals to g m1 m2 per r squared. The g value is 6.67 times 10 to the power of negative 11 Newton meter squared per kilogram squared. The mass of the two students is 50 kg and 40 kg. The distance between them is 0.50 meter. And the answer is 5.34 times 10 to the power of negative 7 Newton. So this value is too small to overcome the frictional force between the students and the surface they are on. That is why the students are not accelerated towards each other. Okay, now we try the second example. What is the force of attraction between the Earth and the Sun? Given that mass of the Sun is 2 times 10 to the power of 30 kg, mass of the Earth is 6 times 10 to the power of 24 kg, and distance from the Earth to the Sun is 1.5 times 10 to the power of 11 meter. So the solution is, using the formula F equals to gm1 m2 per r squared, substituting g 6.67 times 10 to the power of negative 11 Newton meter squared per kilogram squared, mass of the Sun, then mass of the Earth, and distance from the Earth to the Sun. So the answer is 3.56 times 10 to the power of 22 Newton. And this is an enormous force. So the bigger objects, like Earth and Sun, exert a stronger gravitational force than smaller ones, like the mass of the two students. The end.